Okay, great. Good morning, everyone. It's great to see you. Thank you for the invite. It's always a great honor to come back to the conference. In fact, I first spoke here, I think, in 2019, and that turned out to be a great experience. In particular, I met some of my co-authors at that conference, and we've been working on marathon data analysis ever since. And I'd like to talk to you this morning about some of our recent research where we've been looking at analysing large data sets of running activities with a particular focus on marathon runners, obviously. And this talk is based on a sports science paper that we've recently published where we've looked at the training patterns and training intensity distributions of more than 100,000 runners. And I'd like to tell you this morning about some of our key findings. Before I start, I have a bit of a confession to make. So I'm not a sports scientist. I'm an AI guy. I'm a computer scientist. And I've been focusing on machine learning in an area called recommender systems for the last 25 or 30 years. And I've been building systems for recommending books and music and gadgets to end users. And about 10 or 12 years ago, I was having a bit of a midlife crisis. And I thought, well, is that all there is to do in the world? Recommend movies and books and gadgets to people? I thought maybe I'll either buy an open-top sports car or how about I run a marathon instead? So I decided I'll run a marathon. And then as a data science guy, I decided, I better start analysing some marathon data. And so that was the start of this journey. And I feel like a much better human being as a result. And I realised at the time that some of the skills that I had dovetailed very nicely with some of the challenges that existed in the space of sports science, and particularly when I was looking at how people train for and race in marathons. I noticed that there was a very rich supply of data. Almost everything we do, every activity is logged these days. So we know an awful lot about what people are doing. People are wearing watches and bringing smartphones as they run and tracking a huge amount of detail about those activities. And at the same time, I think marathon runners in particular are a very motivated group. They're eager to find out about how they could improve their training and what they should or shouldn't be doing to improve their chances of a PB at their next race. So that was a very interesting opportunity to start to bring data science ideas and machine learning ideas to the world of marathon runners. And it quickly became clear to me that there was not just one or two interesting tasks to look at, but a whole host, many different challenges, many different tasks, where it felt like AI and machine learning and recommender systems might be able to add some significant value, whether it's to improve how people train, or maybe prepare for a race during tapering, for instance, helping people to pace their races, and then looking at recovery after a race. We're on to the present study. Today I want to look at a recent study that explores the training characteristics of a large cohort of runners. Now, it's true that there's been plenty of work looking at training intensity distribution of elite athletes. We still don't really know which approach is correct, but much less work has been done when we're looking at recreational runners, and I'm much more interested in how recreational runners are training. So our work is one of the first really large-scale analyses of recreational training patterns, and we're using real-world data from more than 100,000 unique runners who've run almost 150,000 marathons. And the data set that we're using is part of a data sharing agreement we have with Strava, which includes a very large collection of anonymized running activities. So we're going to concentrate on a subset of nearly 120,000 unique runners who've completed more than 150,000 marathons during the period 2014 to 2017. These runners were chosen for this study because the Strava dataset includes training activities for the 16-week period that brings us up to race day. Each of the Strava activities that we have consists of timing and distance and elevation data at 100-meter intervals. So for every logged Strava activity, we know their distance, their time, their elevation in 100-meter intervals. And we turn that into grade-adjusted pacing information. So we have average grade adjusted pace for every 100 meters of their training activity. And in this work, we're particularly interested in modeling the training intensity distributions of runners. So to model the training intensity of runners, we need to understand their training zones. Now, many of you will be familiar with 5 or 6 zone models which rely on heart rate thresholds. We're not using heart rate data in this particular study. We use a simpler 3-zone model based on moderate, heavy, and severe intensity domains within which physiological responses are similar. And the zone boundaries then correspond to certain physiological thresholds, such as critical speed and lactate threshold. Now, many of you will know critical speed is the highest speed an athlete can sustain for an extended period at a steady state. And we've previously shown in some other work how we can estimate critical speed from pacing data. And in this 3-zone model, critical speed demarks the boundary between zones 2, heavy, and zones 3, severe exercise. The boundary between zones 1 and 2 is marked by the lactate threshold. We can't measure this directly, but again, recent work has shown us that this can be estimated to be just over 83% of critical speed. That's based on a recent meta-analysis. So now we can use our grade-adjusted pacing data to estimate critical speed, which gives us the boundary between zones 2 and 3, and from that to estimate the zones 1 and 2. So we can look at every activity and determine how much time runners are spending in zone 1, 2, and 3 during those activities. And for this study, we're interested in distinguishing between 4 common training intensity distributions, somewhat simplified. So polarized training, when the time spent in zone 1 and zone 2 and zone 3 is greater than the time spent in zone 2. Pyramidal, if time spent in zone 1 is greater than time spent in zone 2, which is greater than the time spent in zone 3. Threshold, if time spent in zone 2 is greater than the time spent in zone 1 or zone 3. And finally, HIT, where the time spent in zone 3 is greater than the time spent in zone 1 or zone 2. Now, we're using a simpler version of polarized training here because we're not identifying particular zone proportions. Usually in polarized training, people talk about spending 80% of your time in zone 1 and 20% of your time in zone 3, for example. We're not so strict on our definition of polarized training for this study. And we look at exploring various training characteristics such as weekly training volume and intensity and how they vary based on runner ability. So for runner ability, we're looking at their marathon finish times binned into different finish time intervals. And we look at how this varies with gender, with age, and with phase of training. So how far into their 16-week training are they? By way of a summary, I hope you can see some of the data here on the slide, but let me just give you a sense of a couple of the features of our runners in this data set. So not surprisingly, most of our runners, about 70%, are male, but this still allows for a large volume of female runners. We have more than 28,000 female runners in this data set. On average, these runners are training for just over 3 days per week, or 3 times per week. They accumulate weekly volumes of about 45 kilometers on average. This includes a long run of approximately 20 kilometers. And on average, our runners are completing the marathon in just over 3 hours and 50 minutes. Male runners are a little faster, 3 hours and 43 minutes. Female runners a little slower, 4 hours and 13 minutes. Our younger runners, with an average age of 33 years old, are about 8 minutes faster than older runners with an average age of 48 years old. Let's start by looking at training volume. Here we show how training volume, measured in terms of mean weekly distance, kilometers, varies with runner ability. So on the x-axis, you can see that we've divided up the finish time, marathon finish time, into 30-minute bins. We also indicate the mean and standard deviation of the finish times in each of those bins. So from left to right, we're going from faster runners to slower runners. And this chart, and on the y-axis then we're showing mean weekly distance. And this chart shows 4 lines, each corresponding to a different 4-week period during training before race day, reflecting the various phases of training over the 16 weeks up to race day. And perhaps the most striking result is how much weekly volume changes with ability. In particular, we can see that the fastest runners accumulate 3 times the weekly distance of slower runners. Weekly volume declines steeply with finish time up to about the 3.5-hour mark, and then more gradually after that. And we can also see that as training progresses, weekly volume progresses, except for the 4 weeks directly before race day, which have lower weekly volumes as runners begin to taper off for their marathon. And we observe quite similar results when we compare male and female runners, although largely speaking, female runners generally have a lower weekly volume at a specific finish time range. And we see similar results when we're comparing younger runners and older runners. A correlation analysis that we've conducted indicates a strong negative correlation between finish times and total training volume and total training minutes. So in other words, greater weekly volume is, perhaps not surprisingly, associated with faster finish times. And we also find a strong negative correlation between finish times and the number of long runs, or the total cumulative long run volume during training. Of course, training volume is just part of the story we want to tell here. We're also interested in the intensity of training. And here we see a similar chart to the one previously. This time, we've got our marathon finish time intervals on the x-axis, but now we're displaying the average number of weekly minutes spent in each of our 3 training zones, zone 1, 2, and 3. There are 3 color-coded groups of 4 lines. Each colored group corresponds to a different training zone. So the green lines are for zone 1, the yellow lines for zone 2, the red lines for zone 3. And within each of these colored zone groups, we have our 4 lines for the different 4-week periods during training, during the 16 weeks of training. And the striking result here is that we can see how the extra training volume that faster runners are accumulating is almost exclusively based on zone 1 training. In contrast, the training volumes in zone 2 and zone 3 remain relatively stable across the different ability intervals. So faster runners are doing a lot more training, but most of that additional volume occurs in zone 1. And we see very similar results when we compare male and female runners, and again when we compare younger and older runners. We've also looked to see how this translates into different training intensity distribution for runners, again with varying ability levels. As a reminder, we're going to focus on 4 different training intensity distributions: polarized, pyramidal, threshold, and HIT. And overall, we're finding that about 49%, a little over 49% of training time is spent in zone 1. About 35% is in zone 2, and just over 15% of training time is in zone 3. However, training intensity distributions vary quite considerably with runner ability. Pyramidal training intensity distributions are the most common training intensity distribution that we find in our data set. And interestingly, genuine polarized training intensity distributions, so we're always told 80-20 running, these polarized distributions are a good thing. We find that they're relatively uncommon, at least within this Strava data set. Now, in the paper, sports medicine paper, we provide a very detailed analysis of training intensity distribution frequency by ability and by training period. There's too much detail to go into in this short talk, but I'll just give you a sense of our findings here. So here I'm looking at the training intensity distribution frequencies for the two fastest groups of runners, so the fastest and second fastest cohorts of runners, top to bottom. And as we move from left to right, the graphs illustrate how training intensity distributions vary as we approach race day. And each bar chart displays the relative frequency of the 4 different training intensity distributions types: pyramidal, polarized, threshold, and HIT. And we can observe that amongst these faster runners, pyramidal training intensity distributions are by far the most common form, with some evidence of threshold training as well. In comparison, here are the charts for the 2 slowest groups of runners. And you can see that there's a much more even spread of training intensity distribution types. So pyramidal and threshold types are still the most common, but pyramidal no longer dominates in the way that it did for the fastest groups of runners. We also conducted a regression analysis using marathon finish time as a dependent variable. We wanted to explore the relationship between various training features and marathon finish time. Now, there's a very high collinearity amongst the fraction of time that you spend in zone 1, 2, and 3. So we constructed 3 separate regression models here. One focused on zone 1, including a feature for fraction of time spent in zone 1, a second for fraction of time spent in zone 2, and a third model that focused fraction of time spent in zone 3. All 3 models demonstrate similar predictive performance. So we're getting R-squared values of around about 0.6 in terms of our ability to predict marathon finish time. We can see here that all other things being equal, and I'll just call out a few key results from these slides. All other things being equal, each unit increase in the percentage of training time in zone 1 results in a finish time decrease of approximately 18 seconds of marathon finish time. So a greater fraction of your training done in zone 1 improves your marathon finish time. In contrast, we can see that spending more time in zone 2 or zone 3 is actually associated with an increase in finish time. Right? So more time in zone 1 was a decrease in finish time, better marathon finish time. More time in zone 2 or zone 3 results in an increase in finish time, a poorer marathon finish time. For example, each unit increase in the percentage of time spent in zone 3 is associated with about a 45-second increase in marathon finish time at the end of the day. It's also worth noting that in our data set, the fastest runners spend about 20% of their time training in zone 2, and they did not adopt a truly polarized approach to training. And previously, we've shown that for recreational runners, they complete their marathon at about 85% of their critical speed. So that's just above the zone 1, zone 2 boundary. So it's plausible that some runners are accumulating training at their marathon pace in the upper part of zone 2 training. Thus, time spent in zone 2 may also provide greater training specificity, which is a central tenet of successful marathon training paradigms. Now, before I conclude, it's probably worth noting several important limitations of this work. To begin with, we've just focused on 16 weeks of training prior to race day. And obviously, for many of these runners, they've been training systematically for months and months, if not years and years, before the marathon. So it would certainly be worth looking at taking a longer horizon on training for some of these runners. Importantly, we've also used estimates of critical speed to estimate zone boundaries. And in particular, we've used a fixed fraction of critical speed, approximately 83% of critical speed, to estimate the lactate threshold, the boundary between zone 1 and zone 2. So using a fixed threshold or a fixed fraction for all runners may not be ideal. It may be the case that runners of different ability, we should be using different fractions to estimate their lactate threshold. So that's certainly worthy of additional work. Obviously, as well, this is a retrospective study, a descriptive study. It would be unsafe to draw causal inferences from the associations that we're finding at this stage. And it's worth pointing out that the data we have from Strava contains running data only. We don't know what else these runners are doing. We don't know if they're engaging in other activities, cross-training, strength and conditioning, etc. We only have access to the running activities that they have recorded. It is also conceivable that they didn't record all of their running activities. But in conclusion, in this work, we've aimed to investigate the training characteristics of runners before a marathon using a large data set of recreational runners. And we found that the pyramidal approach to training with a high training volume is the hallmark of successful marathon performance. In short, more is better, especially if that more is in zone 1. So thank you for your attention. I'm happy to ask any questions that you might have at this point or later. Thank you.
Just to get to the mic. Thank you, Barry. That was very, very interesting. I was wondering, because I know Strava have recently started giving you predicted times for performances. I wondered if your data might have had any influence over the way they predict marathon times, or if that's something they've done with other data.
Oh, I'm sure they've copied me directly and haven't told me. I don't know. It's certainly true to say Strava have been interested in looking at what they can do with their data. I suspect, everyone is piling AI into these models at the moment. Strava have a lot more information than we have in this Strava data set as well. So increasingly now they will have heart rate information. They're starting to incorporate other sensors into their as well. So I think I'm sure they're using similar sorts of machine learning models to make their predictions. These models are going to get better and stronger over time. Yeah.
I've got one more, but let's go.
Thanks, Barry. Really, really interesting. I noticed that a few of the runners would be represented multiple times in the marathons because they've done more than one marathon.
Yeah.
Do you have to take that into account at all if they're represented multiple times?
We didn't oh yeah, I need to stay by the mic. We didn't look at that in any more detail in this study. These are the other thing I should have said, which I didn't, is these are the fastest marathon times in a given year for those runners. So we focused on marathons that we felt were their kind of A marathon. Some of these runners may have run other marathons that they were using as training runs. But I think it would be worth looking at that. In the past, I've done some work looking at the personal best marathons that runners have run as well. So I think, it's worth considering.
Hello there. I just wanted to ask about slower runners. I know that some people follow different sorts of marathon training plans. I know that many of them are based on mileage, and that's used as a volume, but some use time spent running as their volume, and naturally if you're a slower runner you will cover less distance over that period of time, and does that take that into account? Yeah,
it should. We've looked at not just the volume but also the time they've spent in these different training zones, so it does to a certain extent. It is worth pointing out that for slower runners, for some of their zone 1 activities, they're probably at close to walking pace to get into zone 1, so that might... You might find that slower runners are actually less likely to spend time in zone 1 because they think, I'm just walking, I need to run. But I think it is worth looking at that in more detail. Yeah, I think in general what we'd like to do is take this sort of work and try and figure out, so what's a good way to train for the marathon for a slower runner versus a moderately fast runner versus a very fast runner. I think that there's a lot known about the fastest runners and the really disciplined runners, but much less is known about how much slower runners and casual runners are training. And I think there's a lot of interesting data hidden in the Strava data set that we could bring to the fore.
I've got one more. I noticed that you mentioned that there's the 45 seconds was the potential difference And obviously over a long marathon, that's not a huge amount of time.
Yeah.
Can you comment on that, like in terms of the magnitude of the predictions that you're...
Well, you see, and that's a unit increase in the fraction of time spent in zone 3. So if you spent a lot more time in zone 3, potentially that could be a lot more than 45 seconds. Right. So, you know, but generally, there's a lot of other things that can go wrong in a marathon, you know, so you need to factor that in with how you're actually running your race, conditions on the day. Previously, we've shown that going out too fast has a big impact on your marathon. Taking poor pacing decisions may make you more inclined to hit the wall or for pace to slow later in the race. So I think there's a lot of hazards in running a marathon.
Yeah, for sure. Brilliant. Any more questions, or shall we move on? All right, thanks very much, Barry.
Thank you.